one question that I've got for each of you is, what do you see as exciting opportunities in the platform technology side of genomics investment? Is it the decentralization of sequencing, like those two examples, or is it something else? Noel, you want to start it off?
Sure. So from our perspective, we think that there's a lot of places for innovation, obviously, but with a centralized model with Illumina sequencers, you're pushing down towards cheaper and cheaper costs per genome, but all of that requires centralization and scale, right, for you to be able to get that kind of price range. On the other end, with Oxford and Two Poor Guys and some of these other new companies that we've seen, you have smaller instruments, decentralization, but they're typically very expensive. But they also are very good at very specific applications. And we feel like for us, for example, we're Illumina Ventures, but we're allowed to invest in sequencing companies. What we like to see when we think about new sequencing platforms is what can you do that centralized sequencing cannot get you. And that's actually quite interesting. Oxford Nanopore is being used in a variety of different ways by some of the companies actually that we're looking at investing in, making use of the long reads, sequence until you get a hit, those types of applications. The innovation there is really interesting, and you just can't do that on a short read sequencer like Illumina. But again, it's a trade-off, so you just have to find your target market and your very specific application that you want to address if you're going for that type of decentralized model. And then on the centralized side, it's kind of hard to beat Illumina at their game currently, although we're also looking for the next Illumina. So that's kind of, we view the market as split in those two ways, with the vast majority, at least currently, being centralized still.
From different angles, sort of all points to the same direction. One is, in general, we are looking for unique, differentiated technology that address unmet needs, and that's almost like our guiding principle of making investments, especially in the healthcare arena. And the other is from the perspective that the escalating healthcare costs, particularly in the U.S., is unsustainable. So anything, sort of expanding access while lowering the cost is something to our interest. So that, leads us into all kinds of different areas, including platform technologies that make things, cheaper, better, faster. So I guess, the technology is advancing, but in the meantime, making it practical in the clinical setting is a whole different layers of challenges. So we are looking at, sometimes we're not really looking at something, breakthrough technology. We're looking at something that actually makes something, already in principle possible, but now make it a lot more practical that you can actually widen the access of everyday people through those, more accessible clinical applications.
Direct-to-consumer genomics. Started with companies like 23andMe. Now we're in the era of Helix, which I recognize some connections here. Some people would call Helix recreational genomics. You get your genome sequenced once, and then you can go to the App Store, buy various apps, and tell you what wine you're going to like, what's the best exercise regimen for you. Like or dislike? Let's just go down.
That being said, we've seen a lot of direct-to-consumer products come out on the market recently. It's getting easier because, especially at scale, as I was mentioning, it's so cheap to sequence now that everyone can do it, at least to a certain extent. We have not yet seen kind of the killer application for something that's direct-to-consumer. I think genetics and genomics is complicated. Even as a PhD, it's very complicated for me. In the US, with our healthcare system and our physicians, typically most physicians aren't even trained to understand what to order, and if they do order it, how to interpret. And so, you know, before the actual healthcare industry catches on to genomics and genetic testing, you know, and I'm talking about things outside of, for example, cancer, where I think there's been a lot more innovation and people are a little bit more sophisticated. But until we see much more of the genetics and genomics being useful for actual healthcare, I think it might be hard to see how it could be disruptive in a consumer setting. I feel like the training and sophistication will lag behind the technology for a few years.
I think because some of these direct-to-consumer tests are negatively impacting their reputation as it relates to quality. I've had a friend who's an identical twin, and her sister got their test done and it came back differently, which is interesting. My team actually came up with some examples to just put into question the whole quality around genetic testing. So this company called Vinome, which tells you what wines you may enjoy as a result of your genetic makeup, skin fit, so how to get perfect skin based on your genomics. Bloom, discover what makes your child unique. Poo print, identifies a species of animals who poo on your lawn. Like, there's an unbelievable list, and I won't go through it, but I was chuckling to myself as I was reading it, because there's no shortage of tests that are direct to consumer. So it's more a question of how are we actually going to prepare for it. Back to my previous point, what are the tools that we're actually going to make available so that when you show up to your doctor, at least there's a number that you could call to be informed somewhat, like maybe it's a genetic counselor. Sometimes you're going to find these incidental findings, like now 23andMe can do BRCA testing. Like there's no pre and post genetic counseling that's associated with 23andMe the last I checked. Not to mention all the ethical implications. So my husband is a clinical bioethicist, and he supports the Personalized Genome Project at Sick Kids, and that's why we have all sorts of nerdy conversations in our house. But the ethics around direct-to-consumer, like people don't know, because like how many people read the terms and conditions of, associated with the I accept button? I don't think many, and some of that is you're selling your data. People have absolutely no idea what that actually means. So what's the right consent? How do we actually get in front of this? And while I'm a fan of appropriate regulation, the problem with regulations, of course, is that they sometimes get outdated faster than they can be updated. And so I feel for governments trying to get in front of this quick-moving train. But it's a train that we're certainly not going to stop by standing in front of. So we ought to figure out what are the right tracks we ought to build to direct which path this train is heading down.
What is the responsibility of the consumer if they're in possession of this information and they don't disclose? And so there are a lot of issues that are out there now that could be problematic, but I do think that it does run the risk of making those hard tests much harder to believe, and I think anything that starts to erode the confidence that we have in the healthcare system and the quality of diagnostics leads to the rise of companies like Theranos that can play on that gray area that people don't sort of understand. It's sort of kind of believable. It's kind of like an April Fool's joke where you're like, oh, that seems unbelievable, and then you realize it's April 1st. But I think if you're playing around with this technology, it sounds just scientific enough that maybe that's true. And those people that aren't doing the business that we are every day, they don't have the filters that we have or the context that we have to be able to really understand that. So I think it can be really risky.